Hello and welcome to Cracking the Cryptic. So today I'm going to just have a look at a puzzle from today's Times, a regular classic Sudoku as we call it, graded Fiendish. So this is just the standard Sudoku you find in all the papers, but this is one of the Times' harder calibers. They do have a higher category called Super Fiendish, so this is just Fiendish, and we'll see how we go. So, as always, this is all about advice, and my advice is to start looking for duplicated numbers that are the same in either columns or rows of boxes. And what I mean by that is taking, say, one set of down boxes. Let's find numbers that are repeated in here because they can help fix numbers in the third box. So for instance, the two fours here, we've got one at the top and one at the bottom. They're using up columns 2 and 3. So the only 4 in this middle box must be either in this cell or in this cell. And I'm kind of writing them in lightly. That's my pencil marks for this method. Now, also in this group of boxes, we can see 8s and 7s. And these look even more useful because the 8s are in column 1 and 2, the 7s are in column 1 and 2, and they're both in the bottom two boxes. So the 8s and 7s in the top box must both be in column 3. And that's good because that means that those two cells must be 8 and 7. And because of that, we know that 8, 7, 4 are there, 9 is there. These other 5 cells must be 1, 2, 5, 6, 3. So something we can now tell about this 1 that we couldn't tell immediately was that it must be in one of these two cells here. At the start of the puzzle, it could theoretically have been there or there, but we've now ruled that out by that 8 and 7 having to fill those. So we can now very confidently put 1 there or there. It's also quite interesting, having kind of exhausted the doubles from this set of boxes, and having a quick look at this set of boxes and noting that there are 2 6s and 2 4s here. And because the 6s are in row 2 and row 3, the 6 in this box must be either in column 1 or column 2. So the notation again that I'm using there is to put numbers into boxes when we can really narrow down where the number is in that box. So in this box, we know that the 6s are either in those top 2 cells, the 8 and 7 are in those 2 in some order, and the 1s are in those. And given all the numbers that we've used, we've only got 2, 5 and 3 to fill those 2 and one of those. So it's a decent start there. Now we notice that 4s in the top row of boxes were available, and they prove that the 4 in the middle box here must be in the top row. Again, carrying on the method, looking at this set of boxes, we can see a 1 duplicated, so we know that 1 in the middle box must be in one of those 2 cells. The middle one is ruled out by the one below it. And then coming down to the bottom here, we can see 2 9s, so we know 9 is either there or there. And we can see 2 5s, and that's even better because the only place for a 5 in the bottom row is now here. So in that goes, and that's fixed. That has ruled out a cell for that 1, so 1 must be either here, and that could have been a 9 as well, or here. And that's decent progress. Now the other things we haven't done is the 2 remaining down groups of boxes. So the only repeated digits I can see here are 5 and 6. The 6 must be either here or here. The 5 not so good because it could be in any of those 3 cells. I'm not going to enter the 5s in those cells at the moment because it's a bit less powerful when the numbers could occupy 3 cells rather than just 2. Now down here we have 1s, 4s and 9s. Let's start with the 9s. They prove that the third 9 in the group must be either there or there. The 1s and 4s are quite interesting. They're in columns 7 and 8, and they're both in the top 2 boxes. So the 1s and 4s must be in these 3 cells in the bottom box, and the bottom row already has a 4 and a 1. So in fact, 1 and 4 have to be in those 2 cells. And that's really narrowing things down a little bit there. So that's quite handy too. So down here we've got 1, 4. We've got 1, 4, 5, 9. 5, 4, 2, 1, 9. And really now I'm just cycling around numbers in my head, trying to see if what we've proved is giving us anything a bit more. So down here we've got 1, 4, 5, 9 in that box. So we've only put, I think, 1 number in entirely, but on the other hand I do think we've made some good progress. Now we need to find something a bit beyond these kind of shoots of numbers that we've been looking at so far. And something that might be worth doing is noting that this 6 rules out this cell. So suddenly 6 in this box can't be in the bottom row. We know it can't be in the top row because of that 6, so 6 here must be either there or there. And as usual, if we make a reasonable deduction, then we take it across in the other direction. So 6 in this middle set of boxes, there's 1 in the middle row, there's 1 in the top row, the 6 here must be in the bottom row, and it must be one of those 2. And that's kind of a useful bit of progress in some ways. Now we're looking for something else we can do. So this box, we've got 1, 8, 7, 4, 6. 9, no, not so good. Now, given that sort of individual cell was there, I wonder if this one is going to give us any help. Yes, this can't be a 1 because of this 1. And because of this 1, these 2 can't be 1s. So the only 1s left in this top central box must be either there or there. And as we bring that down, we realize that this one can't be a 1 anymore. So that's good. We know that the 1 in the central box must be here. We don't need to take that across because we'd already figured out where it was sitting across, but at least we've got another number placed now. Now we can, you may well be moving ahead of me, maybe what we should be looking for is something that is fixed by nature of the cells. What we've really been looking at so far is patterns, but sometimes individual cells can really matter as well. But it's knowing what to look for is the hard bit of Sudoku. The deductions are obviously fairly straightforward once you know what to look for. It's working out what you could be looking for. So up here in this top box, that 5 is quite suggestive. Those 3 can't be 5s. This one can't be a 5 because of this 5. So 5 must be in one of these 2 cells here. And because of that 5 and this 5, the only place for a 5 in this central right box now is there, and that must be a 5. We now have across the middle we have 5, 1, 9. What that does is helps with this 8 over here. That 8 can't be there or there. I mean, there can't be another 8 there or there. So 8 in this box now has to be in the top row. And again, we're narrowing it down, lots of pencil marks in. I know some people have mentioned in the comments that they prefer doing Sudoku without pencil marks. Well, you can do that. It's slightly more of a rigorous approach, but it doesn't help finish very fast, in my view. Certainly not once the puzzle is of any significant difficulty. Now, what else can we find? 5, 4, 2, 1, 9, 6, 3. Yes, as I said, sometimes finding individual cells that are of significance is helpful. And this one here, you can see that 6, 1, 3, 4, 5, 9 are not possible because they're in the same column. That leaves 2, 8, 7. And in this row, 7 and 8 are ruled out, so this cell must be 2. And we might not have spotted that for a while, to be fair. There may be other things going on. That fixes something about the 2 in that box. It's quite interesting as well for this cell. This cell must be an 8 or 7. Now, because of the way that I'm using pencil marks, I don't want to write 8 or 7 in that, because I'm using pencil marks to mean places where they're limited in a box, and 7s and 8s aren't very well limited in this box, but that cell must be 8 or 7. This other cell in the top row we already established is either 8 or 7. So that might become useful at some point. We know that they must be 5, 8 and 7, those 3 cells between them. We know 6 is here, 4 is here somewhere. That doesn't necessarily advance us enormously, but it might become useful later. 3, 4, 5, 1, 9, 4, 5, 7, 6, 5, 7, 1, 9s. It does sometimes help to kind of get a fix on digits that are appearing a lot in the puzzle, because you might be able to kind of finish off a set of digits sometimes, although I haven't noticed an ability to do that anywhere yet in this one. We've got 5, 7, 6, 2, 1, 4. I'm not making any immediate breakthroughs, as you can see. And sometimes it is just a case of waiting for the light to dawn briefly in some area. I do think that this cell this box is looking quite powerful, because we know so much of it, and we've got 2 and 7 limited to this area, to this little area here, but that's not necessarily enabling me to break through there. How about this column? 1, 4, 9, 5, 6, 2. No, my eyes are really flitting around now, trying to find something else that we can use. Okay, we can, because of this 5, because that 8 and 7 has blocked off those cells, 5 in the top box can only be here or here. That's limiting 5 here to only there or there. And now I've noticed that after that 5 that we just put here, there's a similar situation for 5s here. And just in doing that, 5 must be there or there, because of the 5s above and below and there. Now, the 7s and 9s in this central box as well are quite limited, because of that 7 and that 7, that 9 and that 9 in the same rows and columns. 7s and 9s have to be in here as well. So in fact, we've found a kind of important triple there. 5, 7 and 9 must be in those 3. And what that does is it means that this 3 can't be there. It must be in the bottom row here. So 3 must be in the bottom row there, and the 3 over here must be in one of these 2 cells. So that's interesting of itself. But what that's really telling us now about this cell here is it can't be 5197 from its row, it can't be 2, 4 from its column, it can't be 8 from its box, and we've just determined it can't be 3. The only number left is the 6 that was possible. So that one can't be a 6. So that now has fixed the 6 down here. That fixes 9 and 1. We've got a complete box, which is always a useful staging post, I think. We know that because 8, 7 are fixed up there, this must be 5, 3 in that order in the middle. That's not a 3 anymore. 5, 3, 6, 1, 7, 8. And this must be 9, because there can't be a 9 in this column. These are now 4 and 2 in some order. that makes this 1 6 fixed. 6 1 9 4 8 7. That's 5 2 3 going down. So that's 2 3. This is any of 2 3 5, and that's 3 or 5. Now this 6 here is fixed. That puts the only possible 6 in this box here because these are limited to 1 and 4. That fixes this 6. And I think our 6s are all done now. 5 2 6 9 1 4. 3 must be in the bottom row there. That means this one's a 3. In fact, I hadn't noticed the 4 1 have been resolved by a 1. 9 3 5 6 1 4 2 2 is there. 4 is at the top. No, that hasn't. This 9 that we've put in here has fixed the 9 there. That fixes 7 and 5. We've got 2 there now. 4 2 6 5 9 3 8 7 3 6 5 7 6. And now I think we really have broken this apart. These 2 must be 2 7. That must leave 4 8. That's 3 7, although I don't know in what order. That's 8 now. That makes this one 7. That fixes this 8 7. 1 4 3 4 2 6 5 1 9 8 7. Yeah, that's a 4. That's 2. That's 4. 4 7 6 5 1 9. So then we have 3 2 8. And this is all just standard elimination at this point. And we're, I think, finishing off the puzzle now, which is a relief in many ways. A bit of a sticky bit in the middle, and that was quite a difficult way to overcome it with that triple. I'm not normally great at spotting triples like that, so I'm glad we got it done in the end. But a tricky hurdle to overcome, and in some ways the slightly more classic pencil marks technique of writing possibles for a given cell might have worked slightly better there. So there we are, that's the puzzle done. I hope the technique of beginning it was helpful, and the things of what you need to look out for. So that's today's Sudoku. Hope to see you again on Cracking the Cryptic. Thank you for your